Okay, in example 5, we're going to try to take these ideas and apply it to probably like the most complicated looking example. Only complicated looking because there's a series of variables in here, but we're going to do all the same things that we have before. So in this one, it says that because line AJ, line AJ is parallel to BK and parallel to CL, and JK over here is congruent to KL, then AB must be congruent to BC. All right, so what they just said there. These three parallel lines create proportional segments. Now they've identified what the proportion is. In this one, the proportion is 1 to 1. If you see the marking here, we have our congruency symbols that say that these two line segments are the same length. They're written differently. One of them is written as 4y minus 1. One of them is written as y plus 8, but they're the same length. So if this is a 1 to 1 proportion, then these two must be 1 to 1. 2x plus 8 must be equal to 7x minus 12. These are also equal to each other, these two segments. Okay, so that's just definition of congruence. If these two are congruent, these two must be congruent because the sides are proportional. So it says we can do some substitution. For BC, we can put in for BC, we can put in 7x minus 2. Let's get this so it's the right size for me to write on. We can put in 7x minus 2. Get that going. 7x minus 12, I mean. At that stage, we want to get our x's together on one side, so we'll subtract 2x from both sides, like it says. We'll end up with 5x minus 12. We'll add 5 is what goes in that spot. We'll add 12 to both sides, so we'll get 20 is 5x, and then we'll divide each side by 5 to get 4 for x. We'll do the same thing on the right side. So 4y minus 1 should equal y plus 8. Subtracting y from both sides would leave only 3 y's on the left. Adding 1 to each side would get our 3 y's by themselves and would show that they equal 9. And then dividing each side by 3 would say that each y by itself was equal to 3. Okay, so a little bit of algebra tacked onto the end there, but in the end, we're just doing algebra while pointing out the same kind of proportionality ideas as before. If we take these parallel lines, they chop these lines that they transverse into proportional segments. Okay, so the same ratio between these two things will apply to the ratio between these two. They give us that these two are the same length, so that means that these two must be the same length. The proportion over here is 1 to 1, which means the proportion over here is 1 to 1.